Hello, we are trying to find the dimensions of the pool. So we have this pool with a square garden on each end of the pool. So I'm making the assumption that the square gardens have the same area, and I'm saying let G be one side length of the square. And I'm also considering L to be the length of one side of the pool. Now the question says that we cannot exceed the width of 140 feet. So I just tried to make a picture here. It is not drawn to scale, so please trust me. We have two square gardens and we have this pool here. So now, based on the information represented in this picture, I'm going to write two equations and then we will see how to find the width and length of the pool that will give the maximum area. So the first equation I can write is I have G plus L plus G equals 140, or I can also say this is 2G plus L equals 140. So this is my first equation. Now I'm going to write an equation for the area of the pool. So the area of the pool is length times width of the pool, right? So I'm going to say L times G. Okay, this is my second equation. Now we have to determine the width and length of the pool that will determine the maximum area. So since we have to find the maximum area, we have to tweak our equation for the area here. So I have two variables L and G. So I will try and rewrite this using a single variable. You see, we have the equation 1 that has two variables. Maybe I can use that and get some help here. So what I'm going to do is instead of L, I'm going to rewrite L using G. So from the equation 1, I can say L equals 140 minus 2G. So now the area of the pool, I can rewrite this as L times, okay, it's not L. We wanted to replace L using G. So let me change that here. So L is 140 minus 2G. Then you multiply that by G. So if I simplify this, I have 140 times G, that's 140G, minus 2G times G, that's minus 2G squared. So I'm going to write this in the standard form, meaning the term with the highest exponent first. So this will be negative 2G squared plus 140. Okay, so now if you remember, this is a quadratic equation because the degree of this equation is 2. So since we are solving for the maximum area, I can relate that to what that maximum means in the quadratic equation or quadratic expression or a quadratic function. So in a quadratic function, the maximum always occurs at the vertex. So if we can find the vertex, then that's like finding the value of G for the maximum area of the pool. So let's find the vertex. So the vertex is given by, let me write that here. Okay. The vertex for the quadratic function is given by negative b over 2a. So b is the coefficient of the variable g, which will be 140 here. A is the coefficient of the highest degree uh, part in the term. So that's negative 2. So this will be the negative sign 140 divided by 2 times. Let me actually write that here. A equals negative 2 and B equals 140. Okay. So this is what I'm substituting here. So now we have negative 140 divided by negative 4. You know, if you're dividing two negative numbers, the result is positive. And this is 4 times 3 is 12. Remainder 2, 2, 0, 20. 4 times 5 is a 20. So this is actually, remember we are solving the quadratic equation. So this is actually the value for G. Okay. So now we have G equals 35. Let me actually include the units here, 35 feet. Now we can find the value of L because we know that L is given by the expression 140 minus 2G. So let's substitute here 140 minus 2 times G is 35. So this will be 140 minus 70, which is actually 70 feet. Okay. So if you want the maximum area, our pool should have the length 70 feet. I'm going to put that here, 70 feet. The longer side is 70 feet, and the shorter side, which happens to be one side of the square garden, that will be 35 feet. Okay. So let me write that here, dimensions of the pool. Dimensions of the pool is 70 feet by 35 feet.